Next up, let's take a look at compound inequalities. Now, there are two types of compound inequalities, the and inequality and the or inequality. So what does it mean for a number to be the solution to an and inequality versus an or inequality? Now, the and inequality, every value must satisfy both inequalities. Okay, so that means every value that you're going to say is a solution must satisfy both inequalities. By the way, a compound inequality is when you have two inequalities. Something like, if I said x is greater than -5 and x is less than 2. Question is, what numbers would work in both? Well, let's talk about -10 for a moment, all right? The number -10, is -10 a solution to this compound inequality? Well, -10 is smaller than 2, so it works in this second one over here. But -10 is not bigger than -5 on a number line. So we can say that -10 is not a solution as it does not work in the first inequality. Okay, so what could be a solution? Well, how about -4? So let's think about -4. Is -4 bigger than -5? Well, yes, it is, so it works in the first inequality. Is -4 smaller than 2? Yes, it is, so it works in the second inequality. So -4 is a solution because it works in both inequalities. Basically, when you're solving a compound inequality that has an and, your key word is you're looking for things to overlap. When we graph it, we're going to be looking for an overlapping area, all right? And we're going to see this on the next slide, so we'll come back to that in a minute. So how is an or inequality different? Well, an or inequality means the solution is, a solution has to satisfy at least one of the inequalities. Okay, it doesn't have to work in both. Okay, it might work in both, but it doesn't have to. So let's take a look at the same two. Actually, no, not the same two inequalities. Well, let's take a look at, let's say, x is greater than 4 or x is less than 0. Okay, let's take a look at number 6. Is 6 a solution to this? Well, 6 is bigger than 4, so it works in the first one. We don't care about the second one. Okay, so 6 is a solution because it works in the first inequality. Okay, it works in the first inequality. What about, say, the number 3? Is 3 greater than 4? And 3 is not greater than 4, but that's okay. Maybe it works in the other one. Is 3 less than 0? No. So because it doesn't work in either spot, I get to say 3 is not a solution. Doesn't work in either one. All right, what about -5? Is -5 a solution to this compound inequality? So let's see, -5 is not bigger than 4. It does not work over there. But -5 is smaller than 0. So -5 is a solution because it works in the second inequality. Oopsies, a little bit more space to write, sorry. Okay, so it works in the second inequality. So when it comes to or, they don't have to overlap. I kind of refer to this as anything goes. Meaning, if you can graph it, you get to keep it. All right, so let's take a look at some problems where we don't have to solve first, just how do we graph these compound inequalities? All right, so graphing on a number line, okay? I only need to mark the numbers of interest. All right, so I've got two numbers here, and I want to make sure the smaller one is on the left, the bigger one is on the right. So for this first problem, I've got 2 and -3, so I'm going to put -3 on the left and 2 on the right. Now I've got x is less than 2. So x is less than 2 is everything to the left of 2. And I'm going to cover my whole number line. And then I've got x is greater than or equal to -3. Greater than or equal to, so everything this way. Now this is an and inequality, so I need to figure out what numbers work for both spots, okay? What numbers work for both inequalities? So when I take a look, this is where my overlap is. This is the overlap, okay? So it starts at -3, including -3, but it ends at 2, not including the 2. So what does my final number line look like? All right, so here's what we're going to end up with. Let me redraw it smaller right here. So I'm going to have -3 and 2, close circle on the -3, open circle on the 2, and I'm going to play connect the dots. Everything in the middle is where I was overlapping, numbers that worked for both inequalities at the same time. All right, same inequalities, but with an or statement instead. Okay, so I have the same starting bit. Let's do this one in green. Okay, so I've got the -3 and the +2. I've got x is less than, and then x is greater than or equal to. Okay, same setup as number 5 started with, but now we've got an or, which means if I can graph it, I can keep it. So that means the numbers over here work, the numbers in the middle work, the numbers on the right work. Well, this isn't everything goes. I've got all the numbers covered by these two different number lines. So my final answer here is actually going to be all real numbers. I'm still going to mark that my numbers of interest were a -3 and a 2. But now I'm going to cover the whole thing and say that this is all real numbers. Okay. All right. A traditional and will have number lines going in opposite directions, facing each other and overlapping in the middle. If I had that set up, but it says or, it's going to end up being in all real numbers because of what we've just seen here. Now let's take a look at the next two. All right. I've got -1 and +2. I need x to be less than or equal to -1. So there's an equal to, so it's a closed circle. And then x is x is greater than 2. X is greater than 2. X is greater than 2. All right. Now this is an and I want to know, where do these overlap? Well, I've got one set of numbers here, one set of numbers here, but there's no overlap. Okay, so I'm going to make a note that this is no overlap, which means there's no solution. And you know what? I just realized I did this wrong. Backtrack, Miss Morrow. All right. Who can figure out what I did wrong? I did this inequality incorrectly right here. I graphed x is less than or equal to. This says x is greater than or equal to. So let's go back. One of your jobs over the course of this year is going to be to find my mistakes and tell me when I am wrong. All right. And I'm going to thank you for telling me that. All right. So x is greater than or equal to. negative 1, and x is greater than 2. All right, here we go again. We want to know where do they overlap because it's an and they overlap here. This is my overlapping zone, all right? So it's going to end up being a one-sided inequality, but it does have an overlapping section now that I have fixed it, okay? So that overlap, I'm still going to mark both numbers, but really I only need the one that is of interest, which is the 2. I can't include the 2 in the second inequality, so I can't include it in my final answer. So the final answer is just x is greater than 2. All right. Same situation, but with an or. So if I replicate that graph, let's see, negative 1 and 2, close circle, over, open circle, over. Okay, now I have or. Or means if I can graph it, I can keep it. So the numbers in this section right here work. The numbers where they overlap work. So everything bigger than or equal to negative 1 works. So my final answer here, again, my numbers are negative 1 and 2. And everything from negative 1, including negative 1 and up, worked in one or the other inequality, okay? So that's graphing compound inequalities. And now describing the solution set, we could describe in words. The first one, number 5, it's all numbers between negative 3 and 2, including negative 3, but not including 2. For problem number 6, the one in green, it's all real numbers. For problem number 7, it's all numbers greater than 2, not including 2. And for number 8, our pink, it's all numbers greater than or equal to negative 1. So everything negative 1 and higher. All right, so that's graphing compound inequalities. In the next video, we're going to take a look at how to solve and then graph with these compound inequalities.